Mm.
Hi everyone. Today we are going to discuss one of the important topic of trigonometry, that is inverse trigonometric functions. Right. The important concepts of this chapter are: first one, define inverse of a trigonometric functions. Second one, the graphs of inverse trigonometric functions. And the third one, properties of inverse trigonometric functions. Okay. Now, I am going to ask a question. Which type of functions have inverse? I repeat, which type of functions have inverse? To answer this, I will show you some examples. See example 1. Let f mapping from n to n defined by f of x equal to 2x plus 3. Okay, range of f that is equal to set containing f of 1, f of 2, f of 3 and so on. That is equal to 5, comma 7, comma 9 and so on. That is not equal to codomain. Clearly, f is 1, 1 but not onto. Suppose we define inverse relation of f. For that, let 2x plus 3 is equal to y. That implies x is equal to y minus 3 by 2. Now, G mapping from n to n defined by g of x equal to x minus 3 by 2. Now, g of 1 that is equal to minus 1. Minus 1 does not belong to the codomain. Therefore, 1 has no image in the codomain. Therefore, g is only a relation but not a function. So, I am not able to define inverse function in this case. Okay, now see one more example. Let f mapping from R to closed interval 0, comma infinity defined by f of x equal to x square. X square is an even function. So f of minus 1 equal to f of 1, that is equal to 1. And f of x equal to x square is always non-negative. Therefore, f is onto but not 1, 1. Right? In this case also, we define inverse relation of f. For that, x square is equal to y implies x equal to plus or minus root y. Now, G mapping from closed interval 0, comma infinity to R defined by g of x equal to plus or minus root x. Now, g of 1 is equal to plus or minus 1. Therefore, g of x is always double valued. So that in this case also, g is just a relation but not a function. Right? In this case also, I am not able to define inverse of a function. Now, how to define inverse of a function? Now, see some another example. Okay, in this case, the domain is restricted from R to closed interval 0, comma infinity. F mapping from closed interval 0, comma infinity to closed interval 0, comma infinity defined by f of x equal to x square, right? Clearly, f is both 1, 1 and onto. In this case also, we define inverse relation of f. For that, x square equal to y implies x equal to root y. Now, g mapping from closed interval 0 comma infinity to closed interval 0 comma infinity defined by g of x equal to root x. Clearly, the relation g is a function and also it is both 1, 1 and onto. And g circle f of x is equal to f circle g of x equal to x. So, I got the answer to the question. Therefore, g is the inverse of f. Okay, right. So, if a comma B are sets and F mapping from A to B is a bisection. If F mapping from A to B is a bisection, okay, from the above examples, then G mapping from B to A is the inverse of the function F if G circle F equal to IA and F circle G is equal to IB. Now we are verifying the trigonometric functions are bisective or not. Okay, see the domains and ranges of trigonometric function in the table. Right, the domain of sine and cos is the same, that is a real number set. Now, if x not equal to 2n plus 1 into pi by 2, then tan and secant are defined. Therefore, the domain of tan and secant is set of all real numbers except integral multiple of odd multiple of pi by 2. Now, if x are not equal to n pi, then cot and cosecant are defined. Therefore, the domain of cot and cosecant are set of real numbers except integral multiples of pi. Right, these are the domains and ranges mentioned in the table. Right, observe that sine 60 degrees is equal to sine 120 degrees, cos 60 degrees equal to cos 120 degrees. Also, the periodic nature of trigonometric functions. Therefore, all the trigonometric functions are many one and hence they are not bisective. Okay, so now how to define inverse? Okay, so now in this situation we restrict their domains such that they are bisective. For any t belong to closed interval minus 1 comma 1, there exists unique x belong to closed interval minus pi by 2 comma pi by 2 such that f of x equal to t. Also, this interval is a subinterval of largest length on which sine function is a bisective. Okay, right. Now, the restricted domains in the table as shown this, right. The domain of sine, tan and cosecant are same, that is closed interval minus pi by 2 comma pi by 2. But tan is not defined at x equal to plus or minus pi by 2. So delete these two numbers from the domain of sine. Also, cosecant is not defined at x is equal to 0. So 0 is deleted from the domain of sine. Now the remaining functions cos, cot and secant, the domain of these three functions is closed interval 0, pi. But see the domain of cot. Cot is not defined at x is equal to 0 and pi. So the domain is open interval 0, pi. Now secant also not defined at x equal to pi by 2. So pi by 2 is deleted from the domain of cos. Now these are the restricted domains. In these domains, all the trigonometric functions are 1 to 1 and hence they are bisective. Okay, now define trigonometric functions. The function sine inverse from minus 1 comma 1 to closed interval minus pi by 2 comma pi by 2 defined by, this definition is very important, defined by sine inverse x equal to theta if and only if all the theorems are proved by using these definitions. Okay, sine inverse x equal to theta if and only if theta belong to closed interval minus pi by 2 comma pi by 2 and sine theta is equal to x for all x belong to closed interval minus 1 comma 1 is called the inverse sine function. This function is also denoted by arc sine, right? Now, similarly, we can define the inverse of cosine, tangent, cotangent, secant, cosecant by taking suitable domain as given below. Okay. Now, see the domain and ranges of inverse trigonometric functions in this table, right? The domain of sine inverse and cos inverse is same, that is closed interval minus 1 comma 1. Domain of tan inverse and cot inverse is same, that is capital R. The domain of secant inverse and cosecant inverse is same, that is open interval minus infinity comma closed interval minus 1 union closed interval 1 comma infinity. Also see the ranges. Okay, the range of sine inverse, tan inverse and cosecant inverse are same except some values. Okay, similarly the ranges of cos inverse, cot inverse and secant inverse are same except some values.